Okay, moving on to the second half of lesson 3.5, graphing using the slope and the intercept. So far, we've learned how to graph two other ways. The first way we learn how to graph is by making a table. So the ways that we graph linear equations. The first is by making a table. The second is by finding the x and the y intercepts. So our third way is using the slope and the intercept, which this way is actually going to end up being the easiest way the more you practice it and the more you use it. So, graphing using the slope and intercept. To graph a linear equation using the slope and the intercept, we first solve the equation or get the equation in slope-intercept form, which remember is y equals nx plus b. Step 2 is to identify the slope and the y-intercept, which is what we were just practicing before. Our next step is to plot the y-intercept. Plot the point 0b. Step 4 is to apply the slope. Draw a slope triangle to locate the second point. Step 5 is to connect. Okay? So, step 1, solve/get the equation into slope-intercept form. We're going to start with just that step. So example 1 says, graph the equation 3x plus y equals 2. So we're going to follow step by step. Go through the process. Step 1 is to solve for slope-intercept form. So in order to get something in slope-intercept form, I need to solve for y. Well, in this case, what is happening to y that I need to reverse? Well, looks like 3x is being added to y. So we are going to do the opposite. We are going to subtract 3x. And we get y is equal. Remember, when you put something in slope-intercept form, it is important to rewrite it so that the x value is first. You can start it out as 2 minus 3x, but make sure when you rewrite it the second time that you write the x first, so the negative 3x, and it's going to be plus 2. Okay, it's going to make it a lot easier in the long run. So now, step 2, if you look at your notes, says identify the slope and the y-intercept. So the slope in this case, our m, is equal to negative 3. Remember I said I always want you to put it over a fraction, so over 1. If there's not a fraction, then you can always put it over 1. Our y-intercept is b equals 2, which in this case is going to be the point 0, 2. Okay, once you find b, you can write out your y-intercept. It's 0, 2. It's always 0, whatever the b is, 0, b. So, step 3, plot the y-intercept. Plot 0b. So let's do that. 0, 2. That's my y-intercept. So the next step is the more difficult step. Applying the slope. We're on to step 4. Draw a slope triangle to locate a second point. So when you're reading slope, we have m is equal to negative 3 over 1. This is also the same thing as 3 over negative 1. Okay, it doesn't matter where the negative is as long as it's with one of the numbers. But we're going to focus on this. So, we are here. Our slope, remember, represents rise over run. So when you're applying the slope, rise, think of that as going up or down. Over run, think of it as running left or right. You have to rise before you can run. So you're always going to go up and down and then left and right. Our rise is -3. So from here, if we're going -3, we're not going to be going up 3. We're going to be going down 1, 2, 3. This is our triangle. And then our run, okay, which is our left or our right, is going to be 1. And it's going to be a positive 1 because our 3 is negative and our 1 is positive. So we're going to be going to the right 1. And you can keep doing this. So from here, we can go down 1, 2, 3, and right 1. And this is what they were talking about by this triangle here. Okay, down 3 and right 1. And connect those points. Notice that you have a negative slope, so your line should be going downward. If it was a positive slope, it would be going upward. Okay? Now, the reason I also had you write this as 3 divided by -1 is because of this. Let's say I'm at this point, and I want to follow this slope. It says my rise, remember that's my up or down, is 3. So I'd go up 1, 2, 3, right? Because it's a positive in this case. And then my run, which is my left or right, is -1. So in this case, I would go from back 1, which still ends up on that same line. Okay, so the slope works in both directions. Let's move on to example 2. Step 1, solve for y. So we have 5x minus 2y equals 4. Well, what's happening to y? The first thing that's happening to y is that it's being multiplied by -2. Then what's happening is it's being added by 5x, because remember the 5 is positive. Okay, if there's nothing there, it's going to be positive. The negative only belongs to that 2. So we need to do the reverse opposite. Instead of adding 5x, we're going to subtract 5x. Instead of multiplying by -2, we are going to divide by -2. Let's go ahead and do that now. So we subtract 5x from both sides. We get -2y, because that negative stays with the 2. And then from here, remember, so those cancel. You cannot combine these. But it is important that we put the x value first. So yes, it is important that we put the x first. So we're going to put -5x, then decide if your b is positive or negative. In this case, it's going to be +4. All I did was put this right there rather than after the 4. Then from here, instead of multiplying by -2, I need to divide every single thing by -2. This cancels, and we get y is equal to -5 halves x. Actually, this becomes a positive 5 halves x, right? Because negative divided by negative. Plus 4 divided by -2. Well, 4 divided by -2, it's a positive divided by a negative, so it's going to be -2. Our second step is to identify our slope and our y-intercept. So identify our m and our b. In this case, our m is going to be 5 halves, and our b is -2. So, more specifically, our m, 5/2, so our rise over run, right, is going to be 5/2. And our y-intercept is going to be 0, -2. Because it's where it crosses the y-axis. So we're going to go first to where y is negative, where the y-intercept is, which is right here, 0, -2. Then we're going to apply the slope. So in this case, we have rise over 1, 5 over 2. Both of the numbers are positive. So from this point, our rise is 5. So we're going to go in the positive direction when going up and down. 1, 2, 3, 4, 5. Our run, which goes left or right, is +2. 1, 2. And then we plot our point. We can keep applying that slope. Go up 1, 2, 3, 4, 5. And then we run 2. And then from here, connect your points, and always remember your errors, because that means that the graph goes on forever and ever and ever. And that is where we are going to stop today.